Hello everyone, welcome to 7 Olds. I am Hemant. In this video, we'll be testing our interrupt-based send and receive SPI APIs. So first, let's get into the demo of the project, and then let's explore how we did that. So whenever I send the command that is on from this Arduino board through SPI to this board, and user LED will be turned on. And again, when I send off through SPI protocol from Arduino board to STM, the user LED will be turned off. That is the project. Let's test it here. I'll type on and press enter. You can see LED is not turned on. When I press enter, the LED will be turned on. Similarly, when I press off, when I enter off and press enter, the LED will be turned off. You can see that. This was the project, and let's look into how this works. Before understanding the interrupt, let's understand behind the scenes of this. It's very different from GPIO interrupts. There is no EXTI block or nothing like that, but SPI interrupt can be triggered by various things. There are three things to note. Whenever this flag is raised, SPI interrupt will be triggered, and even this flag, transmission empty buffer or RX filled buffer, this interrupt will be, if these registers are enabled, then SPI interrupt will be triggered. And for any other flag, if any these flags are raised, if you enable this bit, then interrupt will be triggered. So to find out which triggered the interrupt, we need to look into the SR status register of SPI, then decide which of these flags made to trigger the SPI interrupt. Whenever there is a buffer to send from Arduino to STM, we'll be using another GPIO interrupt. That is, I have connected the pin number 8 here to this C6. So whenever there is a message to send from Arduino to this 8 pin will be pulled low, and that is how we get to know that there is something waiting from Arduino to STM32. So when we get that interrupt on GPIO, we will just enable our SPI2 and we start receiving byte by byte. For every byte received, we have a callback function. I will show. This is my source code, and whenever there is an interrupt, I will be calling the SPI handling function, where we will decide how the interrupt occurred, and we will be performing the intended code for that. And for every byte received, we will be storing each byte into the receive buffer, and at last byte in the buffer, we will just store the null character. So that says that it's the end of the message or end of the string. We are using interrupt based send and receive. I'll be sending a dummy data here and receive the real value from the Arduino board, and byte by byte we receive it, and after everything completes, we just check whether the received buffer is off or on. And if the received buffer is off, then I'll just reset the LED, and if it is on, I'll set the LED. This was the explanation of the source code, and I have developed the SPI driver.c file with all the APIs and some of the APIs which is just exposed to the user. And here is the SPI driver.h file. It has all the macros which are necessary to perform this operation.